The easiest max-min problems are ones where the word problem gives you the equation built in. In other words, the word problem isn't a word problem because they give you all the information. Here's a height problem, and it says find the maximum height of a ball thrown from one friend to another if its path follows this. So if we just sort of analyze the equation, we've got h for height and t for time. That would mean that h is your y, so height is here, and t is your x, so time would be here. And does it make sense that your y-intercept, or in this case h-intercept, is 9? So somebody's on a building throwing a ball, because they're already 9 meters above. The ball goes up in the air, and do you see that this is a parabola that opens down because of the negative? So it's going to have a maximum at the vertex. So we're going to find a maximum height. We're really looking for a maximum y value. In this case, h value, because it's a maximum height. And the vertex would tell you what time that actually happens. How do we find a vertex? We find a vertex by completing the square. So I take my equation, I'd have to factor out the negative 2, right, to complete the square. I keep my plus 9 over here. This will give me t squared. Taking a negative out of a positive will be negative. Taking the 2 out of 4 would be 2. Leave a space and leave a space. And then we complete the square. Are you getting good at seeing the hint of the minus 2 to tell you what goes in here? T minus, the minus tells you it's going to be minus. And what number? 1. And if there's a 1 there, then in your first space there would have to be a plus 1. But what have you actually done by adding a 1 in that space? You've actually subtracted 2. So what do we have to do to compensate? We have to add 2. If you would have subtracted 1, you would have got 8 as your vertex, and something definitely would have gone wrong, because that would be like you threw the ball down to begin with. And the maximum is lower than where it actually started. Something in your brain should say, this is not working right. Okay? But instead, we add the 2, which gives us a plus 11 here, and we can now say the vertex is 1, 11, but it's a word problem, so we need to end this with a statement. It asks us to find the maximum height. The maximum height, oops, that's not an H. And this value here will always be a max or a min. This is the x, or in this case the t, that gives us it. We need to include units if the question has units. So the maximum height is 11 meters. Didn't ask for this, but it's just so that we can talk about if I analyze what the 1 stands for, that maximum height happened 1 second after it was thrown. So in our maximum problems, we're going to find the vertex, the y-coordinate, or in this case, yeah, I guess it wasn't ever y. We get used to what we're used to doing. This is a little bit of a mistake here. It's not actually a y, right? It was an h in this question. But we can talk about it being a y-coordinate because we're so used to x's and y's. But in this case, it's our h-coordinate is our maximum. And our x-coordinate, which in this case was t, that's the time. This is the easiest max-min problem because the equation was given to us. Our next ones, what makes these questions harder is you have to come up with the equation from the word problem. And we're going to look at different types of questions. Type 1 here was a height question. Equations are usually given. They're the easiest. type 2 questions. Here we go. Wow, I guess I was already, there we go, height problem, number problem. Number problems and the equation's not given. So now we're going to look at how do we set up the equation and how do we figure out how to do this. Find two numbers whose sum is 12 and whose product is a maximum. So first of all, whatever you want to find as the maximum, that's what your equation will be. Product equals. Product is like your y-coordinate. You want to find the maximum product. And sometimes we start off these word problems by just writing out in words what's happening. Product is multiplication, right? You would take your first number and multiply it by your second number. This doesn't help us solve anything, but it gives us the idea in words of what's happening. A product is one number times another number. Now, we have to set this up so we can use algebra to solve it. So what could be our first number? I'm going to pick something that I'm going to say it's x. I don't know what it is, but it's going to be x. Now, if you can do it with regular numbers, you should be able to come up with your second number in terms of x. So let's start with regular numbers. If one number was 7, what's the other number? 5. Perfect. If one number was 8, what's the other number? 4. How do you know that? Because they have to add up to 12. Okay? So if you can do it that easy, 9 would be 3. If you can do it that easy with numbers, see if your brain can work. Hey, one number is x. What's the other number in terms of x? 12 minus x, right? Because they have to add up to 12. So if you take away the x from the 12, does that make sense? That that's your other number. And now, I'm going to just erase this part here so we have space to finish it. And now, our first number was x. Our second number was 12 minus x. If we distribute this, do you see that you're going to get a parabola? X times the minus x, I'm going to write that first, minus x squared, x times the 12 will be plus 12x. It's a parabola that opens down, which makes its vertex a maximum. We just need to find that vertex, and we can do that by completing the square. You're going to have to factor out the negative, which is like a negative 1. There's no number here. If you want to write a plus 0, because there's nothing there, you can. I factor the negative out, leaving me with x squared. I factor a negative out, that would be minus 12x. I leave a space, and I leave a space. And you're getting really good at completing the square. If you had an x squared minus 12x, it would have to be x minus 6. And if it's a minus 6, what goes in the green space? Plus 36. What have we actually done? By doing that, we've actually subtracted 36. So to compensate, we would add 36. And 0 plus 36 is 36. So we now have our vertex is 6, 36. This is your max. This is the x that did it. What did the question ask? The question asked for the two numbers. What did x stand for? We look back, this is why this part here, really important for us defining what x was. X was our first number. So the first number is 6. The numbers are 6. And what would the second number be then? One number was 6. The second number would be also 6. I don't think the question just asked what the two numbers were, but if we wanted to be even more explicit in our answer, that gave us the max product of 36. Now, if we started to guess and check, like 7 and 5, what's the product? 35. 8 and 4, 32. 9 and 3, 27. 6 and 6, 36. Now, just guessing whole numbers, I would have guessed 6 and 6 would have been the maximum. But what numbers haven't I even tried? I haven't tried decimals. There might be like 6.1 and 5.9. What does that equal to? Something, right? 6.1 and 5.9, 35.99? Oh, so cool. Is that right? Seems like it would be close, but maybe not quite right. Okay. So, we have, again, this one was harder because we had to set up an equation. The equation wanted a maximum product, so we know we had to equal product equals. And what's a product? It's two numbers multiplied by each other. So I wrote it out in words first, and then I figured out in terms of one variable what it would be. I can't use x and y because then I can't solve it. Too many variables. We only need one variable in order to solve it. Okay. Number problems. So what's going to happen in number problems is not always going to be a product that's the maximum. They might tell you like a sum of squares. So you have to square the first number, square the second number, add them together. And that might have to be a minimum. Or all sorts of different things. So you have to read what they're trying to find and then set up the equation according to that. Those are our number problems. Next, area problems. I think these are my favorite ones because I feel like this is a realistic situation. You have a farmer. He has only a certain amount of fencing. He has chickens running all over the place. He wants to enclose them, and usually they'll say in here, they'll add the following word, so you're not allowed to shape. They'll tell you what shape you're going to be using. It would be different if it was triangular. It would be different if it was a circle. Farmers like to make fences in straight lines. It's easier for them to work with. So he's going to make a rectangular coop off the side of his barn. So I'm going to give you a top view here. This is the top view of the barn. And he's smart. He's like, I can use one side of my barn as a fence. That way I can get a bigger area for my chickens. And I'll build a rectangle off of this and use up all 80 meters of my fencing. But depending on what I do, I'm going to get different areas. Like, it would be actually really dumb to make this 1 meter, 1 meter, and 78. Your chickens just can run in straight lines. They don't have much room. They probably wouldn't taste as good either if they're running that way. So that wouldn't make sense. What else could I do? Give me a number for this side. 20. If this is 20, how long is this side? 20. How long is this side? 40. Give me another.
72.
72. Why does that not work? 72 here, what number would over be here?
72.
72 again, and we don't have that much fence. So that wouldn't work. Could go 10, right? Then this would be 10. How much would be here? 60. So you see what you're doing? With numbers, you play out some scenarios. And we're choosing something for here, so I'm going to call that X. How long is this side? X. How long is this side? So with numbers, you could do it quick, but with variables, it takes a little bit of thinking.
80 minus 2x.
80 minus 2x, because you had 80 in total, right? You've used up x here and used up x there. You've used up 2 x's. This is how much you would have left. We want to find the largest area. So we need to set up an equation that area equals, it's a rectangle. If I write it out in words, does it make sense that area is length times width? And now that we've drawn our picture, it really doesn't matter which number you choose for your length and which you choose for your width. Can you see that if you multiply that out, that's going to give you a parabola? Will it open up or open down? Right, if I distribute, I'll put the x squared first. It would be minus 2x squared and then plus 80x. You see that that's a parabola that opens down. So its vertex will be a maximum. So what happens for the most part in real life is the farmer just like starts guessing and checking on paper and comes up with a number. That might work out nice, but the beautiful thing about the algebra is now we don't have to guess and check, so if you know the algebra, it's faster, and you will know it is the maximum, the best possibility. So we'll have to complete the square to find our vertex, which means factoring out the -2. There's no number, I can write plus 0 there if I want. Take out the -2 will be x squared. Negative out of a positive will be negative. Take a 2 out of 80 would give us 40. Now we can complete the square, which you're getting really good at. Minus 40 tells us in here will be, oh, spaces, minus 20. And then what goes in the first green space? 20 times 20 plus 400. What have you actually done though? You've actually subtracted 800. So to compensate, we need to add 800. Whew. And now the most strenuous mental math now, you have to take a 0 and add 800. All right, take a break. That was hot. Breathe. Whew. And so our vertex is 20, 800. The 20 is the x, the 800 is the max. Because we're looking for a maximum. So what did x stand for? Look at your diagram. Right? What did the question ask? The question asked for the dimensions. So the dimensions are, include our units. Well, the x is one side, 20 meters by, what's going to be the other side? 40. You had guessed the biggest one. Right? So the farmer might have done 20 and 40 and found out, I guess we can, if it didn't ask for this, but it's not bad to write down here. And just to practice our units. What would our units be for the area? Meters squared. That's a lot of room for those chickens. Way better than the 1 by 78 I suggested at the beginning. That is only 78 meters squared for those poor chickens.
But like, what if they got like levels? Be like 78 meters deep.
Depends how high the fence is, I guess, for the volume that they have to run around in. Right?
Multiple floors.
Volume becomes, like if we were doing an aquarium question, then the volume would have to come into how much water.
You can't just stack chickens up like that?
And then you're going to jump out of the fence. This could be problematic. So we have our maximum area of 800 meters squared. Okay, and now, I like this question because I think it's very practical. This could be something someone would run into. You could just design a fence and make it, but even if you design it, the more materials you use, the more money it's going to cost you. So you want to use get the biggest space possible. This could be very strategic. Okay. Another place where these ideas are used a lot is in businesses. Businesses want to make as much money as possible. Businesses also want to do as little work as possible. This is human nature, right? If you have a choice, you would be like, what can I do to do the least amount of work and make the most amount of money? I ask my kids, what do you want to do? Oh, I want a job where I don't have to work, that just pays me money. Look at that. Everybody wants that job. That'd be a wonderful job. What happened today? Oh, I didn't work and I made lots of money. Okay, sounds good.
CEO.
Yeah, but it unfortunately doesn't usually work that way. But we want to minimize what we have to do and maximize our profit. So here, I'm going to be a greedy school. We're going to skip to the profit problem. This school happens to have free sweatshirts they got from a company. Instead of giving them to the students for free, they're like, ooh, we can make some money. So they do a survey and they find out that if they sell them for $20, 300 students will buy them. They'll make $6,000. That's kind of exciting. But their greed does not stop there. They're like, what happens if we make them more expensive? Well, if you make something more expensive, there's going to be some people that are like, no, I'm not going to do this, right? But there's another student who's like, I really like that sweatshirt. I'm still going to buy it if it's $25. Then they're like, well, what if we raise it to $30? And then there's a bunch of other kids that say, no, I'm not going to do it. But some will say, I'll still buy it for $30. So the school is like, we want to make the most money possible because we're greedy. They want to find a maximum profit. Well, how do we calculate profit? Because we want a maximum profit, so we're going to need to make an equation that's profit equals. Well, we could look at the profit from one shirt and then multiply that by the number sold. Right? If they sell them at $20, that they profit $20, they'll sell 300. Their total profit would be $6,000. But now this variable comes in. We could increase the price. Every time we increase the price, less people will buy, but maybe we'll still make more money. So what we're going to do is we're going to say let x equal the number of times we increase the price by $5. So then what do they make on one shirt? Well, they started at $20, but every time they add an increase in price, the price or the profit will go up by $5. Does that make sense? How many are sold? Well, when X is 0, they would sell 300. But each time they increase the price by $5, how many people? 30 less. Does it make sense that if I go minus 30x, each time you increase the price, 30 less students buy it? This is the hard part, setting up the equation. We have to write it out with words and then think how we're going to use the change. Change of $5 increases the profit, decreases the amount sold, which would change the overall profit. If I multiply this out, 20 times 300, 6,000. 20 times minus 30, minus 600x. 5 times 30, 300, plus 1,500x. And 5x times this, minus 150x squared. You see that it makes a parabola that opens down. Parabolas that open down have maximums at their vertex. If I rewrite this, combine my like terms, I'll put the x squared first. minus 600 plus 1,500 is plus 900 plus 6,000. Seems like big numbers, but you're going to find it's actually not too bad, even without a calculator. We have to complete the square, so we have to take out the 150. We still have the plus 6,000 here. This will be x squared. How many, okay, take out a negative, it's going to be negative. How many 150s are there in 900? 6. So it'll be minus 6x, which is enough for us to complete the square. The minus 6, this would have to be minus 3. What goes in our first space then? 9. Alright, this might be calculator. It probably would be calculator, but can you do 9 times 150 in your head? Minus 1350, not bad. And so if you actually subtracted 1350 to compensate, we would have to add 1350. And look at this greedy school, oh my goodness. The vertex is 373.50. This is your max. This is X. That's not the price. They're not selling them for $3. If the 3 is the X, we have to go back and say, because the question is, what is the profit and what price? So if X is 3, what's the price? $35. The price of $35 will have a max profit. Look at that greedy school. They got these for free, and they made $7,350 off the students. When they pushed the price up to $35, it was still worth it to do that. If they pushed it higher, if they went to $40, then the amount of students that said no, they're not making as much money. So they're finding that perfect price. Okay? Think about where this happens in real life. Are Winnipeg Jets tickets cheaper or more expensive in playoffs? Way more expensive. Why? Because we're doing good, but how come they can charge more money?
So many people want them.
So many people want them, right? So they have formulas out there. They're trying to make as much money as possible. They could charge $5,000 a ticket for playoffs. Who's gonna go? Only these like super rich people, right? And will the stadium be full? No, Winnipeg doesn't have that many super rich people, right? But playoff tickets in New York are more expensive than playoff tickets in Winnipeg because they have more people, and then that drives up that demand. And so companies are always looking for that. Well, how much can we charge, right? And they would charge you so much money unless another company came along and could charge less. But unfortunately for a sports team, you've only got the one sports team. So now it's based on what people are willing to pay, right? And then other people try to make, if other people think the company didn't do enough, what do? They buy tickets and resell them. Where did that happen last little bit? Like Taylor Swift tickets. They were super cheap, right? Was it super easy to get them? No. Because some people buy a bunch of them and then resold them for a lot more money. So all this idea of supply and demand. So companies are always like trying to figure out what that maximum would be.